All right, let's talk about a huge concept in medicine, something that really is fundamental to how so many drugs work. We're going to get into agonists and antagonists. Now, you may have heard these words thrown around, but what do they actually mean for your body? Well, let's unlock it.
It really comes down to this one simple but kind of powerful question. How is it possible that one tiny little key can open a super important door inside your body, while another one that looks almost identical just gets stuck and jams the whole thing up? The answer to that is the secret sauce behind how a ton of modern medicines get the job done.
So, before we can even begin to understand the keys, we have to talk about the locks. And as it turns out, your body is just full of them.
See, every single cell you have is just covered with these things called receptors. And the absolute best way to picture them is as these tiny microscopic locks or little gateways. They're basically the bouncers at the club door. They get the signals from the outside, and then they tell the cell what to do. And they control pretty much everything. We're talking your heartbeat, your mood, even your breathing. It's all managed by these little locks, just waiting for the right key.
Okay, so if our cells are covered in locks, then what are the keys? Well, this is where the two main stars of our show come into play, the agonists and the antagonists.
And honestly, this right here is the whole concept in a nutshell. If you only remember one thing today, make it this. An agonist is a key that fits the lock perfectly and it opens it. It makes something happen. An antagonist, on the other hand, is a key that also fits, but instead of opening the door, it just gets stuck. It jams the lock so nothing else can get in. So really, it all comes down to their action. The agonist activates a receptor. It flips a switch to on. The antagonist blocks that same receptor, basically preventing anyone from flipping that switch. Two keys, two totally different jobs. Right, so let's zoom in on that first key for a minute, the one that actually opens the lock. That's our agonist.
So here's the more sciencey definition. It's basically any substance, whether it's something your body makes naturally or it's a medicine you take, that latches onto one of those receptor locks and, this is the important part, it triggers a response. It gets things going.
And how do they pull this off? Well, they are amazing mimics. See, agonists work by perfectly imitating your body's own natural keys, things like hormones or neurotransmitters. They're the ultimate copycats, tricking that lock into thinking they're the real deal and swinging the door wide open.
This quote from the source material just sums it up so well. It's a two-part punch. It binds to the lock, and then it triggers a response. It's an active player all the way.
So what does this actually look like in real life? A perfect example is Albuterol. That's the drug in a lot of asthma inhalers. It works as an agonist. It binds to these specific receptors in your lungs and mimics the natural signal that tells your airways to just relax and open up. It is literally the key that unlocks easier breathing for millions.
Okay, so we've met the key that opens things up. Now let's talk about its opposite number, the key that jams the lock, the antagonist. Here's the flip side of the coin. An antagonist also binds to that same receptor. It fits just right, but, and this is the huge difference, it does not trigger any response. It just sits there. And by doing that, it physically blocks anything else from using that lock.
So you know how agonists were the copycats? Well, antagonists are more like molecular bodyguards. Their whole job is to stand in the doorway and stop the body's own natural keys from getting inside to activate the receptor. They're all about blocking the signal.
And again, the source gives us this perfectly clear distinction. It binds, but that's it. Story over. No trigger, no action, no response. It's just taking up space. Very, very important space.
A classic example of an antagonist in action is a type of drug called a beta blocker, something like Propranolol. You see it used all the time for high blood pressure. What it does is it jams the locks on heart cells that would normally get all fired up by stress signals like adrenaline. So by blocking those signals, it helps keep your heart rate and your blood pressure from shooting through the roof. So let's step back a bit. We've got one key that turns things on and another that stops things from turning on. And this simple little duality, it isn't just some neat biological trick. It is, quite literally, the key to unlocking so much of modern medicine. This table just lays it all out perfectly. Let's just run through it real quick. For function, you've got agonists activating and antagonists blocking. Simple. For effect, agonists mimic the natural signal, while antagonists prevent it from ever binding. For examples, we've got our friends Albuterol for asthma and Propranolol for high blood pressure. And that brings us to the big one, clinical use. Doctors use agonists to stimulate a system and antagonists to suppress one. That's the whole ballgame right there.
So, why should you care about all this? Well, it's pretty simple. Doctors use this exact principle every single day. If a system in your body isn't working enough, like your airways closing up, they can give you an agonist to turn it back on. And if a system is going haywire, working too hard, like a racing heart, they can use an antagonist to calm it down. This incredibly simple idea of a lock and a key is the foundation for, thousands of life-saving drugs.
And that kind of leaves us with this really fascinating thought, right? Our bodies are just filled with these locks, and while we figured out what a lot of them do, there are still so many more we're just starting to understand. So the big question is, as we get better and better at mapping out this incredible, complex system, what kind of keys are we going to be able to design in the future? What doors will we be able to unlock? It's pretty exciting to think about.